Hi there, welcome to another video for Junior Cert Higher Level Maths. We're going to continue with coordinate geometry, and today we'll be looking at the distance formula, or the length of a line. First of all, a quick recap of plotting points. When you have a coordinate, the x coordinate always comes first, just like in the alphabet, x then y. The x-axis is the horizontal axis that goes from left to right, and the y-axis is the axis that goes up and down vertically. The point 0, 0 is known as the origin. It's where the two axes meet. And points on the axis are ones that can be kind of tricky sometimes, so they're worth having another look at. All points on the x-axis have a y-coordinate equal to 0. So the red, green and purple dot along the x-axis here, they have the coordinate 1, 0, 2, 0, 3, 0, because their y-coordinate is 0 along the x-axis. And similarly, all points on the y-axis have an x-coordinate equal to 0. So the light blue and the dark purple have coordinates 0, 1, 0, 2, because they're 0 on the x-axis and then up 1 and up 2. Distance between 2 points. So if we have 2 points and we want to find the distance of the line that connects them, here's our first example. We have the point A, which is the origin 0, 0, and another point B, which is 6, 0. And there's that blue line connecting the two of them. You can pause the video now, or if you have a think about it, what is the length of that line? Okay, well, the length of it is going to be 6 units, because it goes from 0 on the x-axis to 1, 2, 3, 4, 5, 6. So it goes from 0 to 6. A straight line, so it is 6. Here's another one. The point C is 2, 2 and D is 9, 2. What's the length of this line? If you said 7, then you'll be correct, because it goes from 2 to 9. Third one, E to F, 3, 1 to 3, 7. What's the length of that line? Again, it'll be 6, because it goes from 1 on the y-axis up 6 boxes. You can just count the boxes. 1, 2, 3, 4, 5, 6. P to Q to R. So what's the length of the line from P to R? So this one, it'll be 9 units, because it goes from -3 to 0, which is 3 units, and then from 0 up to 6. So that'll be another 6 units, so 9 altogether. U to T to S. Again, this one will be 9 units. Because if we're at -2, we have to add on 2 to go to 0, and then from 0 up to 7 is another 7 units. So we have 7 and 2. We've moved 9 units, or 9 boxes altogether. We're measuring the length of all these lines, and you may start to wonder, why do we need a distance formula at all? Can't we just count the number of boxes? Well, what about an example like that? Just counting the boxes doesn't work, because it's not moving along a flat edge of the box. It's going diagonally through some of them, and it goes through some of them more than it goes through other ones. So we could get an estimate, but we cannot get an accurate value. So what we need to do is we need to go and use our distance formula. And the distance formula is based off something called Pythagoras' theorem, which we'll be looking at in greater detail in a later chapter. So let's go straight down to the distance formula now and have a look. Here's our page from the coordinate geometry and the log tables again. The second formula this time is the length of PQ. So that is the distance, or the length, and there's the formula for it. These bars either side of PQ, they mean distance. So the distance from P to Q equals the square root of x2 minus x1, all to be squared, plus y2 minus y1, all to be squared. The distance between 2 points. So here, this is taken out of your book, and it's a nice little example of Pythagoras' theorem and where we're deriving that formula from, but we'll be looking at that in greater detail in a later chapter. Here's an example. So the bars either side of AB mean the distance from A to B, and we have 2 points, 1, 2, and 5, 5. And I've drawn them onto a graph for you so you can see where they're located and the length of the line. But we need to find a value now for the length of the line. Same as with all of these questions in this topic, you need to write out your formula before you begin. And then label your points. Be really careful that they are labeled correctly. That is a common error, and it'd be such a shame to make an error there when you have all your subbing in and calculations correct. And now we can fill in those values into the formula. And don't forget to include your square root sign as well. So x2 is 5 minus x1 is 1 to be squared, plus y2 is 5 minus 2 to be squared. And your calculator will do that for you, but I'm going to do it out for hand so you can see what's happening. It's the square root of 4 to be squared plus 3 to be squared. So this will be the square root of 16 plus 9, the square root of 25, and what number multiplied by itself gives 25? Well, the answer will be 5. So the distance between A and B is 5 units. That's an example using the distance formula. I hope you found it useful.